All right, ladies and gentlemen, I am not there today. When we come together on Friday, or when you come together on Friday, you're going to take a quiz on complex numbers. So what I'm going to do right now is go through the latter part of the homework. I think the first few problems are pretty simple and pretty basic. So what I'm going to do is I'm going to pick up on number 35, and I'm going to work 35 through 71. Now, if there are like huge gaps where people are like, I don't need to see any of these, feel free to skip along in this video. But I'm going to work through them pretty quickly, and then I'll get you another small assignment, give you an answer key to that, and then hopefully you'll be well and prepared for Friday. Okay, so if you got your homework, get it out so we can take a look at this together, and I'm going to get rock and rolling. So here's number 35. Number 35, to simplify this, you got to multiply the top and bottom by negative I. And so that gives you on the top negative I. On the bottom, you have negative I squared, which is negative 1. So you have negative I over 1, which is then just negative I. Okay, this one, let's see here. To multiply, the conjugate is going to be 1 plus 2i, and that's what you have to multiply on both the top and the bottom. So when I FOIL that out on the top, I get what? 2 plus 4i minus 3i minus 6i squared. Let's see. And then on the bottom, you get 1 minus 4i squared. Okay, so on the top, you get when you look at this negative 6i squared, you know that's going to be a positive 6. It's going to be negative 6 times negative 1. So then 2 plus 6 is 8. 4i minus 3i is going to be just plus I. And on the bottom, you have the negative 4i squared, which is going to end up being positive 4, so you're going to get 5. And so you look at that, and that can then split up. If we're thinking about this in terms of A and B values, that would be 8/5 plus 1/5 I, and that would be in the A plus BI form. I know that's how the answers are given in the back of the book. So it'd be 8/5 plus 1/5 I. All right, next. Again, multiply by the conjugate. So the conjugate at the bottom of this one is going to be 2 plus 3i. So you multiply that on the top and bottom. Let's see how this is going to look. Tempted to kind of leave some things alone. I can see a shortcut that's going to happen, but I don't think most people would see it ahead of time, so I'm going to go ahead and just kind of do what I got to do. So FOIL this out, we get what, 52, and then plus 78i plus 26i, and then plus 39i squared, all over 4 minus 3i squared. Okay, the thing that I was seeing ahead of time is I knew that the 4 minus 3i squared is going to simplify down to 13. And right up here, this and this were both factors of 13. And so then, there was going to be some things that we could be able to do, but we'll still be able to do it. So we have 52. 78 and 26 is what, 104i, and then we have this 39i squared, which is the same thing as minus 39, okay, and so let's see, all over 4 minus 3i squared, oh man, 3i squared, what am I thinking? I'm doing all that talk and I'm not doing math right, sorry about that. Obviously that's supposed to be 4 minus 9i squared, and that's how you're going to get the 13. I was already thinking the 13, I forgot to do math. So let's see here. 52 minus 39 is 13. So you have 13 plus 104i all over 13. And let's see. 104 is a factor of 13 as well. 13 times 8. So this is equal to 13 over 13 plus 104 over 13i. And that means that's equal to 1 plus 8i. That's simplified down nicely. All right, next. Sorry about the mistake on that one for a little bit. Let's see here. These out of the way. There we go. Okay, this one. The conjugate of the bottom is 1 plus 2i. So I got to multiply the top and bottom by 1 plus 2i. Let's see here. So we got 10i plus 20i squared. And on the bottom we have 1 minus 4i squared. So on the top, the 20i squared becomes negative 20 plus 10i. And on the bottom, we have 1 minus 4i squared, which is the same thing as 1 plus 4. So we have 5. And that's nice because since the top, they're both multiples of 5. So we got negative 20 fifths plus 10 fifths I. And that clearly reduces to negative 4 plus 2i. All right, let's see here. I'm going to multiply the top and bottom by negative 3i. You could also multiply the top and bottom by positive 3i. It wouldn't drastically change the problem. So let's see here. We get negative 12i minus 18i squared all over negative 9i squared. So what it does when you multiply by that negative, this negative and this becoming negative makes the whole thing positive on the bottom. And so, that's why they just encourage that. Okay, on the top, the negative 18 and the I squared, it's like negative 18 times negative 1. So that's going to give me positive 18 minus 12i all over. On the bottom, you got negative 9. I squared is negative 1. So you get positive 9. That splits up into 18 ninths minus 12 over 9i. 18 ninths is 2. 12 over 9 reduces to 4 thirds. Thirds I. Okay. All right. I think 45 was probably one of the neatest problems on there. It's, a lot of people botch this one. I want to encourage you to look at this problem as if it said 1/5 minus 1/7. And think about exactly how you do this problem. However you would do this problem is the exact same way you need to be able to do this problem over here. Okay, they're the exact same. And so if I think about this, I'd go the common denominator between those two with 5 and 7, I have to it's the product of 5 and 7. So to do that, if I have 1/5, I'm going to multiply the top and bottom by 7. And if I have 1/7, I'm going to multiply the top and bottom by 5. Well, just look at where, these numbers come from. These 5s came from the fact that this was 1/5. And these 7s came from the fact that this is 1/7. And now you do the exact same thing to solve this problem. All right. What you're going to do is you're going to multiply this first one right here, this first fraction. You're going to multiply that by the denominator of the second. And then what we're going to do is we're going to multiply the second fraction, top and bottom, by the denominator of the first. Okay, so let's go ahead and try that. So let's see, this is going to be, so I'm going to kind of rewrite it with a longer fraction bar, 1 plus I, that's what the denominator already is. And now we're going to multiply the top and bottom by 1 minus I. And so that's going to give me, whoops, I don't need an equal sign yet, because I got to do the second fraction. The second fraction, you get minus 1 over, long fraction bar, 1 minus I, that's what's already there. But I got to multiply the top and bottom by 1 plus I. Okay. And then you got to simplify. So on the top, that's really easy. The top's just 1 minus I. On the bottom, again, you're foiling. First times first is 1. 1 times negative I minus I. Inner times inner, you got plus I. Last times last, minus I squared. Minus, again, on the top, that's really easy. It's just 1 times that. On the bottom, first times first, 1 plus I minus I squared. And look at what that is. 1 minus I minus 1 plus I. And I'm going to still keep this as 2 fractions. So these cancel out in the middle. And minus I squared is like negative 1, which is positive 1. So we have 1 plus 1. Same thing happens on the other fraction, 1 plus 1. And so what that equals is just 1 minus I over 2 minus 1 plus I over 2. And we're going to combine that all as one fraction now since it's all over 2. So we have to distribute this negative. We have 1 minus I minus 1, I'm sorry, minus 1, not minus. And then that minus is going to affect that I as well, minus I. And then what happens is we just kind of, we just go, what cancels out? The 1 minus 1 cancels out. And then we have negative I and negative I, which gives me negative 2I. All over 2. The 2's cancel out, so you're left with negative I. I think that's a great problem. The fact that we start out with these two fractions and we're looking for the difference of them, and the result is just negative I. That's pretty amazing that it comes down to be that simple. Okay. All right. Now, when it comes to 47, hopefully, remember that these were really simple. You just had to have some things memorized, and I to the third power is just negative I. We knew that because I to the first power is I, which is square root of negative 1. I to the second power is that squared, so that's going to be negative 1. I to the third power is the same thing as I squared times I. So if I squared is negative 1 times I, which is square root of negative 1, then we have negative square root of negative 1 or negative I. That's what we have here. And then we said that I to the fourth power, you kind of do that by going I to the fourth power is the same thing as I squared times I squared, which is negative 1 times negative 1, which is 1. Okay, so those are the important ones to remember. You should know, you should have these memorized, because then the pattern just continues. But you should have I to the first through I to the fourth memorized. Okay, so then let's get to number 49. This one's kind of cool. All right, we got 3 to the fifth. Really what this becomes is 3 to the fifth, I to the fifth. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So that's 3 to the fifth power. And I to the fifth power is the same thing as I times I to the fourth power. Okay, because that's I to the first power times I to the fourth power gives me I to the fifth power. So that means this is 243. I to the fourth power is just 1. So 243i. That's what that simplifies down to. All right. I to the 1,000th power. Well, 1,000th is the same thing. That's like I to the fourth raised to the 250th power, because when you raise a power to a power, you simply multiply the exponents, and 4 times 250 is 1,000. So this is like saying 1 raised to the 250th power, which is just 1. That's pretty simple. Okay, now it gets a little bit interesting. With all these with all these radicals that still have the negative under the radical, I really want to recommend the very first thing you want to do is get rid of the I. I think that that'll just help. So in this case, I go, what do I multiply together to get negative 25? And you might think negative 5 and 5, but I think about it like this. Well, I've got that negative 1, which I know the square root of, and I've got that 25, which I know the square root of. The 25, the square root of that is 5. The negative 1, the square root of that is I. So the answer is 5i. Same thing happens here. Now, what we have to be careful, and let's review. Yesterday we said, or last time we were together, we said you cannot multiply this and say negative 3, negative 12, which therefore is 36. Because a negative times a negative is a positive. You cannot do that. Don't do that. Okay, that's true that a negative times a negative is a positive, but we're dealing with imaginary numbers. And so really, again, you got to deal with that I first. And go, this first thing is like negative 1 times 3, and the second one is like negative 1 times 12. And so I've got to deal with that I. So this becomes I times the square root of 3 times I times the square root of 12. Now I can do some things. I times I is I squared. And then we have square root of 3 times square root of 12 is square root of 36. And I know the square root of 36 is 6. So I have 6i squared, which is the same thing as 6 times negative 1, which is the same thing as negative 6. Okay? Whereas if I would have just let those negatives at the beginning cancel out, I would have got 6 when the actual answer is negative 6. Now again, this same kind of thing, this same kind of logic follows right here. When we have these negatives under the radicals, man, we want to deal with it and kind of convert it to I earlier versus later. It just kind of saves us a headache. So I say this is 3 minus I times the square root of 5, and then 1 plus I. And that's how I look at this one. Then go ahead and FOIL. First times first gives me 3. Outer gives me plus 3i, inner minus I times square root of 5, and last minus I squared square root of 5. think is what we have. And this is probably my absolute least favorite problem out of the book. And so I apologize that I assigned it because it doesn't simplify nicely at all. This part right here kind of simplifies. That's like saying negative 1, so that's like positive 1. So this is 3 plus 3i minus I times square root of 5 plus square root of 5. The reason I don't like this is because you get 3 plus the square root of 5 as your real part, plus 3i minus I times square root of 5 as your imaginary part. And so the best you can do to simplify that down really is just saying 3 plus square root of 5 plus 3 minus square root of 5 I. And this whole value would be your A, and that would be your B. And that's just so ugly that I just don't really care for this. I'm sorry. I think that this problem does not simplify down well. I think, honestly, it almost looks nicer in the original form. So that's just my own thoughts about it. I love that fraction problem that got us all the way. I love this problem. I think that that's neat that fraction comes down to something so simple like negative I. And then we do problems like this where we do all that work and it really didn't get any simpler than what we started with. And so I don't really care for that problem. All right. Sorry, I accidentally assigned it. Okay, this one, again, let's convert it to i's. We get 2 plus I times the square root of 8. And on the bottom, 1 plus I times the square root of 2. Multiply the top and bottom by the conjugate, 1 minus I square root of 2. 1 minus I square root of 2. FOIL the top. 2 times 1 is 2. 2 times that is going to be negative 2I square root of 2. And then we'll have what? Inner plus I square root of 8. I'm running out of room here. Better scoot some things over. It didn't work. Okay. And then last is going to be minus I squared times the square root of 16. All over the bottom, you're going to 1 times 1 is 1. And you know those middle terms are going to drop out. That's why we do the conjugates like this. So really we just got to focus on multiplying these two, which is 1, and then multiplying these two, which can be negative I squared times the square root of 4. Okay, and now let's simplify that. So we have 2 minus 2i times the square root of 2 plus. Now, 8 is the same thing as 4 times 2. And then we have minus I squared, which is like minus a negative 1, so it's going to be plus 1, times the square root of 16, and the square root of 16 is, of course, 4. All over, you think this is negative 1, so again, minus a negative 1, we have minus the negative 1, which is 1 plus, and then the square root of 4 is 2. So the bottom's going to be 3. So I don't know what happened there. So let's do this. This 4 is going to come out as a 2, and leaving this 2 behind, and this 2 is behind. So that's no big deal. So we're going to get 2 minus 2i times square root of 2 plus 2i times square root of 2 plus, this comes out as a 4. All over on the bottom, 1 plus 2 is 3. So then look at this cancels out with this, and we're left with 2 plus 4 over 3, which is 6 over 3, which is 2. That is probably the greatest problem ever. The fact that all of that simplifies down to 2. And there's a huge shortcut on this one. If you did a little bit of factoring right from the very beginning, you could actually see this. This would be the long way to do the problem. The short way to do the problem would be, you have to kind of see the factoring ahead of time, which is definitely a challenge. But what you could have done is if you saw it, you could say, you know what, that first numerator was really 2 plus, and you could go ahead and take that 2 out and get 2 times the square root of negative 2. Now that was a little bit of a jump. Maybe you didn't see that. Let me help. You have 2 plus the square root of, think about what this is. This is 2 times the negative, or I'm sorry, negative 2 times 4 would get you that negative 8. All over 1 plus square root of negative 2. Okay, well this 4 can come out as a 2. So that would make this a 2 plus 2 times the square root of negative 2 over 1 plus square root of negative 2. And then you notice that there's a 2 here and a 2 here, so you could factor that 2 out to the front and say, this is the same thing as 2 times 1 plus square root of negative 2 over 1 plus square root of negative 2. And then you realize you have the same thing on the top and bottom. Your final answer is just 2. Hey, check it out. Math is true. So that would be the way shortcut, but you'd have to see that factoring ahead of time. And that's kind of a tough one. So you probably end up doing it the long way, and life will go on. Okay, let's look at number 61. Okay, again, we want to think about this in terms of I. So we have negative 1 times 36. On the bottom, we got negative 1 times 2, negative 1 times 9. And then let's look at this. We get 6I on the top. And on the bottom, we have I times the square root of 2 and I times 3, which gives me 6I over I squared 3 times the square root of 2. So what does that give us? 6I over negative 3 times the square root of 2. We're not supposed to leave radicals in the denominator, so we can multiply the top and bottom by square root of 2, but that's really the only thing that simplifies down. So right, we get 6I times the square root of 2 all over negative 6. Because when we multiply the square root of 2 on the top and bottom, that's going to make it 2, and 2 times 3 is this negative 6. So then those cancel out, and we're left with negative I times the square root of 2. That's what I get for 61. All right, and now the home stretch. Now we got to do some algebra with this. Okay, so here's the algebra problems. For these are the first few are really easy. You bump the 49 to the other side, and you get x squared is equal to negative 49. So therefore, x is equal to plus or minus square root of negative 49, which means x is equal to plus or minus the square root of negative 1 times 49. You can bring both of those out. The negative 1 comes out as an I. The 49 comes out as a 7. So you get plus or minus 7i. The next one, again, there's no factors of 5 that add up to be negative 4, so we got to use the quadratic formula. The x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you just go, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so that becomes 4 plus or minus the square root of negative 4 squared is 16. 4 times 5 is 20 all over 2. 16 minus 20 is negative 4. So I have 4 plus or minus the square root of negative 4 all over 2, which this is 4 plus or minus the square root of negative 1 times 4 all over 2. You think about how can I simplify that? Well, this part right here becomes 2i. So you get 4 plus or minus 2i all over 2. And you can take a 2 out of everything. Really, you get 4 over 2 plus or minus 2 over 2i, which is then just 2 plus or minus I. Those are your two possible answers. 2 plus I is an answer, and 2 minus I is an answer. Okay, again, quadratic formula. X is equal to negative b plus or minus the square root of b squared. So that's going to be 2 squared minus 4ac all over 2a. That's negative b plus or minus the square root of 2 squared is 4. 4 times 5 again is 20 all over 2a, which is that. And this just gives me negative 2 plus or minus the square root of negative 16 all over 2. The negative 16, of course, simplifies down to 4i. Hopefully we know that by now. And we get negative 2 over 2 plus or minus 4 over 2i. Negative 2 over 2 is negative 1 plus or minus 2i. Those are my two answers. Negative 1 plus 2i and negative 1 minus 2i. All right, I know this is taking long, but hopefully I'm not moving too fast in these problems. You're understanding it. This is probably the easiest problem ever. Not that it's easy to see ahead of time, but just the fact that your A value is 1, your B value is 1, and your C value is 1. You can't get this wrong. Negative B plus or minus the square root of B squared minus 4AC all over 2A. You know, with all those same values, it just makes that nice. So you get negative 1 plus or minus the square root of 1 minus 4 all over 2. So this just becomes negative 1 plus or minus the square root of negative 3 over 2, which is negative 1 plus or minus I times the square root of 3 all over 2. And then when you simplify that, it becomes negative 1 over 2 plus or minus square root of 3 over 2I. There's your A value and there's your B value. Okay, and the very last one, number 71, this one had just a little bit more going on, but still no different than any of those other ones. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. So this becomes 2 plus or minus the square root of negative 2 squared is 4. Minus 4 times 2 is going to be minus 8 all over 4. So you get 2 plus or minus the square root of negative 4 over 4. You know that that square root of negative 4 is going to be 2I. So we get 2 plus or minus 2I all over 4. And that just reduces to, two fractions. You have 2/4 plus or minus 2/4 I, which is, of course, 1/2 plus or minus 1/2 I. Okay. Hopefully those made sense. If you got to go back and relook at some of these, I hope I didn't make any mistakes or any more mistakes than the one I noticed. Try your best. What I'm going to do is I'm going to have you work through some problems on the same page. On the, I think we were, page 301? 301 or 302. And this time what I want you to do is I want you to do numbers 34 through 54. Okay? You should be able to do 34 through 54 without too much problem. And that'll get you through kind of all those weird ones. And then I have an answer key up front for when you're done with this. When you're done with this, you can check your answers, check how I did it, make sure you understand how to do it. And then you get a practice quiz. And when you get here on class on Friday, I'll have a video that'll go over the practice quiz real quick, or just